Now we'll turn agentic AI from concept into SOC practice. We'll follow the workflow from alert triage through investigation and approved response to capturing lessons learned, so future incidents become faster, smarter, and more consistent. So far, we've built the pieces: agentic AI foundations, security architectures, integrations, coordination patterns, and context engineering. In this module, we apply those pieces to SOC and incident response work, where agents support triage, investigation, response, learning, and human oversight. An agentic SOC workflow starts with noisy signals from security tools and turns them into structured cases. Agents enrich alerts, correlate evidence, investigate likely causes, and propose response options such as contain, eradicate, or monitor. The key principle is control. High-impact actions require analyst approval, especially when business risk is involved. Every step also needs an audit trail of inputs, reasoning, tool calls, outputs, and decisions, so autonomy remains accountable. Intake begins by translating messy vendor alerts into a shared security language. A login event, malware detection, or cloud alert may use different field names, but the agent needs consistent values for entity, time, source, rule, technique, severity, confidence, and asset. That consistency lets it compare signals, apply policy, and route urgent cases correctly. The original alert is still preserved, so investigations remain auditable and forensic detail is not lost. An alert by itself is usually incomplete. It becomes useful when the agent can ask, what asset is involved, who is connected to it, what threats match this pattern, and what business service could be affected. Enrichment turns raw signals into risk judgments. A noisy event on a low-value test host may be closed quickly. The same behavior on an internet-facing regulated application should escalate as a high-risk incident. From there, the agent reduces noise by looking for shared evidence: users, hosts, IPs, cloud accounts, files, processes, and techniques. It also removes repeats from the same rule or telemetry source, so one behavior is not counted 10 times. Then it connects events across time and systems into a single incident candidate. The result is less alert fatigue and a clearer story for the analyst to investigate. Once alerts are enriched and grouped, the agent turns them into an actionable case. That case includes the evidence, affected assets and users, confidence level, suspected attack stage, and recommended next steps. Severity should be explainable, combining alert confidence, asset criticality, attacker behavior, exposure, and business impact. The case is then routed to the right queue or analyst tier, with reasoning clear enough to validate or challenge. After case creation, the agent turns the summary into testable hypotheses, such as credential compromise, malware execution, or lateral movement. For each hypothesis, it identifies the evidence that would confirm or reject it, then recommends the right queries and tools, including EDR, identity logs, DNS, email, or cloud audit data. Just as important, it respects boundaries. The agent should guide investigation toward relevant evidence, not trigger broad access or disruptive actions without approval. Timeline reconstruction turns scattered signals into a defensible incident story. First, the agent normalizes time, because time zones, ingestion delays, and clock drift can make the same event appear hours apart. Next, it correlates shared entities such as user, device, IP, session, process, or cloud role. From there, it maps activity to stages like access, execution, persistence, escalation, movement, and exfiltration. When evidence conflicts or is inferred, the agent should label that uncertainty clearly. An investigation is only useful if a human can trust and act on it. The narrative should answer what happened, who or what was affected, when it occurred, and why it matters. It must also separate confirmed facts from assumptions, unresolved questions, and confidence levels. Every major claim needs a supporting link or artifact, and the same evidence should be framed differently for SOC analysts, incident commanders, system owners, and executives. Response agents are most valuable when they support decisions, not when they rush into disruptive action. For each option, they should connect the recommendation to evidence, expected risk reduction, business impact, reversibility, confidence, and required approval. Isolating a host may stop spread quickly, but disrupt operations. Rotating credentials may be safer, but slower. The goal is a ranked set of choices that helps responders act with speed, accountability, and context. Approval should scale with risk, rather than slow every response equally. Low-risk enrichment or ticket updates can run automatically, or with light analyst review. Actions that touch production, privileged accounts, customer data, or regulated systems need stronger gates. Before approval, the agent should present evidence, rationale, alternatives, and rollback steps. For containment or eradication, it should escalate to the incident commander, system owner, or legal team. Every decision and outcome becomes audit evidence and training data. Once an action is approved, the agent should not improvise or reach directly into production systems. It should use controlled APIs and pre-approved playbooks through SOAR, EDR, identity, firewall, or ticketing platforms. Each step needs policy checks, execution status, and evidence capture. Afterward, the agent verifies the result, watches for side effects, updates the case, and keeps rollback ready. This enables fast response without losing change control, auditability, or operational safety. After an incident, the goal is not just closure, it is learning. An agent can draft the review with the timeline, root cause, impact, actions taken, and remaining gaps. It can also help identify missed detections, slow decisions, unclear ownership, or tool limitations. The most important step is human validation, followed by concrete updates to rules, playbooks, enrichment, escalation paths, and response templates. Those lessons become reusable knowledge for future investigations. Agentic SOC workflows work best as a governed lifecycle. Normalize and enrich alerts, create structured cases, investigate with correlated evidence, respond through approved controls, and learn from every incident. The next step is extending that loop into continuous posture management, moving from faster response to always-on, proactive defense.